Hello 9th standard students. So far we completed exercise 6.1, 6.2 a couple of questions. In this video lesson we will be continuing with exercise 6.2 and we will complete this exercise in this video lesson. So let us start with question number 4, exercise 6.2. Now it is given that PQ and ST are parallel to each other with their measures. PQR is 110 degree and angle RST is 130 degree. You have to find out the measure of this angle QRS. Students, nothing else is given in this question. So there is a construction. You have to draw a line parallel to ST through point R. So what do we do here is we draw XY parallel to ST. Now, if you look at this figure, PQ is already parallel to ST, XY is parallel to XT by construction. Therefore, we conclude that these three lines will be parallel to each other. So this is the solution. I want you to make a note of the solution in your geometry notebook. We have concluded that PQ is parallel to ST parallel to XY. Since all the three lines are parallel to each other, now you decide which two lines you want to take first. Okay, so here in this solution, we have found out angle QRX first. Okay, you could also find out angle SRY in the beginning itself. The choice is yours. So we start like this. QP, which is a ray, is parallel to line XY and QR is the transversal. So these two angles, that is RQP and QRX, this angle, don't they become interior pair of angles? So these two angles will be supplementary. So if angle Q here is 110 degree, what will be the measure of angle QRX? It will be 70 degree because interior angles on the same side of the transversal are supplementary. Now, after having found out this, in the next step, we will find out what is the measure of angle SRY. Have a look. This is the same very diagram. I've drawn dotted line here indicating it is a construction wherein XY is drawn parallel to ST. Now, this angle is 130 degree. Since ray ST is parallel to line XY, if this is 130, what will be the measure of this angle? It will be 50. Again, the same reason, interior angles on the same side of the transversal are supplementary. The lines are parallel. You could also write the reason as pair of interior angles. That is also correct. Now, after having got this as 50, this as 70, how do you find out angle QRS? Angle QRS will be 110 plus 50, okay, that you have to subtract from 180 degree because these are angles in a linear pair. So with that, you get the measure of angle QRS as 60 degree. So QRS is 60. So with this, we have solved one of the question from exercise 6.2. Please make a note of the solution and draw the diagram along with it. It is quite an important question. I put a star on that indicating that you need to practice this. It's pretty important. Now we move on to another question. 6.2, question number 5. Again, this is an important question. Okay, here they have mentioned that AB is parallel to CD and this angle is 50, that is APQ is 50. So let us find out the measure of angle X. Since AB is parallel to CD, PQ is the transversal. Okay, so when this is the transversal, don't you get Z-shaped angle? Look at this, APQ and PQD. They form Z-shaped angles, so they are alternate angles. And alternate angles are congruent. So if this angle is 50, the measure of this angle X will also be 50 because they are alternate angles. So here it's mentioned it is 50. It's very important that you give the reason that they are alternate angles. Okay. Now that this is 50 degree, we have to find out the measure of angle Y. Now students, there are different ways of doing this. One way is, if this is 127 degree, you can find out the measure of this by angles in a linear pair. So this angle will be 180 minus 127 degree. So you get the measure of angle PRQ. Once you get the measure of angle PRQ, X plus Y plus this angle, use angle sum property, which is 180 degree. You can calculate the measure of angle Y. Another method is as per the solution that is given out here. Now, angle APR is equal to angle PRD. You know that AB is parallel to CD and PR is the transversal. So look for Z-shape angles, that is APR congruent to PRD. That means if PRD is 127 degree, what will be the measure of angle APR? It will also be 127 degree. Out of this 127 degree, 50 is already utilized. So what will be Y? Y will be 127 minus 50. Look at the solution out here. So with that, when you solve it, you will get Y as 77 degree. Okay, so this is another way of doing it. So students, I repeat, there are many ways of solving this problem. You can use whichever method you find easy. Okay. Now let us look at another question from this exercise. Exercise 6.2, question number 6. I'm reading out the question. In the given figure, PQ and RS are two mirrors which are placed parallel to each other. An incident ray AB, there is a ray AB that strikes the mirror, and the mirror is PQ, and it strikes the mirror at point B. This incident ray is then reflected. When it reflects, it touches this mirror at point C. And again what happens, it reflects back, that is CD. You have to prove this AB is parallel to CD. Now let's understand. There is a mirror PQ and there is another mirror RS. These two mirrors are parallel to each other. Okay. Now there is one incident ray which touches this mirror at point B. So this arrow is shown upwards, that it is going like this and touching point B. The minute it touches the mirror at B, obviously this has to get reflected back. So this is how it looks when it gets reflected back. But when it reflects back, it touches the mirror again at C. And when it touches the mirror again at C, it has to again reflect back. So this is what you get. Now how do we solve this? Here you have to prove that this line in black is parallel to this line in black, and it is given that this mirror PQ and this mirror RS are parallel to each other. So for that, students, we will take one line like this out here and another line out here. These two lines are called as normal. Okay, and what happens is, when there is an incident ray and a reflected ray, the angle that is formed in between, okay, this, you will notice that they will be congruent. That is, incident ray or the incident angle here that is formed, that is I, will be congruent to the reflected angle, that is R. So you have the incident ray, the reflected ray, the angle that is formed in between, you get the incident angle and the reflected angle, they will always be congruent. Look at the slide here. This is the normal, okay, that is BM is normal here, CN is also called the normal. This is the incident ray touching the mirror AB, this is getting reflected back, and this is CD, which is again getting reflected. Now I have mentioned this as I and this is mentioned as R. That means incident angle and reflected angle. These two angles will be congruent. In physics, you have learned, according to the law of reflection, the incident angle is equal to the reflected angle. So from that, angle 1 is equal to angle 2, angle 3 is equal to angle 4. So students, you draw this diagram in your notebook and mention this from the laws of reflection, this statement, and this is important. Okay, so write down this: 1 is equal to 2 and 3 is equal to 4. And why is this so? Because from the laws of reflection. Okay, now like I said, BM and CN are normals, and what we need to do is, let us prove first that BM and this CN are parallel to each other. Now, why would they be parallel to each other? We have taken BM perpendicular to PQ and CN perpendicular to this mirror RS. Here, BM is perpendicular to PQ and CN is perpendicular to RS. Also, PQ and RS are parallel to each other. So what about BM and CN? They automatically will become parallel, because when you have two perpendiculars, okay, these two perpendiculars, when they are drawn on two parallel lines, then those two perpendicular lines will automatically become parallel. So what is important out here is you have to prove BM is parallel to CN. That we have done. Hope this part is clear. Now, look only at BM and CN. Will angle 2 be congruent to angle 3? Why is that so? Z-shaped angle. Are they not alternate angles? BM and CN and BC is the transversal. So because of the Z-shaped angle, you get 2 congruent to 3. So we have made a note of this, that 2 is congruent to 3. Either you write alternate interior angles, or you could just mention alternate angles. Now, we just mentioned that 2 is congruent to 3, right? But this 2, that is angle 2, can I say that angle 2 is half of ABC? Why is 2 half of ABC? Because 1 and 2 both are equal. So 2 is half of ABC and this 3 is half of BCD, right? Since we just mentioned 2 is equal to 3, what I write here is half of ABC is equal to half of BCD, because above this is 2 equal to 3. But 2 is half of ABC and 3 is half of BCD. So half ABC is equal to half BCD. In this, half and half cancels. So I get angle ABC is equal to angle DCB. Now, if angle ABC is congruent to angle DCB, let's look at where those angles are. That is, this angle ABC full angle is congruent to this full angle. They are Z-shaped angles. They are congruent, but they are alternate angles. So we have proved these alternate angles are congruent. Therefore, what happens to line AB and this line CD? Won't they be parallel? Why would they be parallel? You have learned a theorem in the earlier video lessons. If a transversal intersects two lines, so isn't BC a transversal? Isn't it not intersecting line AB and line CD? So if it intersects two lines such that a pair of alternate interior angle is equal. So we got angle ABC congruent to angle DCB. So we got a pair of angles which are congruent. But what kind of angles are they? They are alternate angles. So in such a case, the lines will be parallel. So this is the reason, and this statement is nothing but the converse of alternate interior angles. If you go through the earlier video lessons, you will understand what is the meaning of converse of alternate interior angles. Converse of alternate interior angle states that when a transversal intersects two lines, and if a pair of alternate angles are congruent, Yes, see, they are congruent and they are alternate. Then what happens to those lines? Those lines will be parallel. So AB will be parallel to CD. So to sum it up, students, in this problem, this angle is congruent to this by the laws of reflection. This angle 3 is congruent to angle 4 by the laws of reflection. Now, this BM is parallel to CN. Therefore, 2 will be congruent to 3. And if 2 is congruent to 3, okay, then this entire angle will be congruent to this entire angle because of this statement. Okay, and that is how you go about proving this. So students, I want you to make a note of this problem also. Write it down in your notebook. So with this, we end this video lesson out here. And in the next video lesson, we will start with exercise 6.3. Okay. Until then, goodbye and take care.